Hello everybody, this is Roy and this is the second video of the core flight system tutorials. In the first video we have seen how to configure the basic core flight system on a regular PC with a Linux distribution Ubuntu. Today we are going to make our own customized app for our own core flight system. So let's start the new video. Let's start a new tutorial. First of all, we need to go to the directory where we have our core flight system. So I suppose you still remember how to configure your own basic configuration of a core flight system. First of all, we open our terminal here in the directory of CFE 6.5, and we need to type the command source and set variables here. We have a shell file called set variables. Now source it. Then we go to the directory called build here and CPU1. CPU1. Alright, so as you can see here, we have a make file we need to configure cFS. My personal suggestion is always make real clean before you do anything. Okay, then make configure. It is done. So our executable of cFS will be in the directory called exe. So let's go to exe. You see the green terms called core Linux.binary. So let's run this executable. Okay, so this is the basic configuration of core flight system. Okay. Control Z. Let's stop the executable. Let's stop the process and go back to CPU1. Make real clean to kill everything we have done before. Now today we are going to make our own customized application for the core flight system. To do this, we need to go to the directory in the tools, and here generate an app code, and you can see that there are a lot of Python scripts, and this is the main script we need to use. So let's go to open the terminal. Let's go to list directories. Okay, cd tools, cd app, and generate application code .py. Let's check the usage of this script. As you can see, we just type Python gen-app-code.py. So you can see the usage of this script. We can decide what our mission is. We can decide the name of the owner. We can decide, or we can specify the output directory, which is where the new app folders and files will be. Then apps indicate the name of the application we want it to be. So Python generate app.code. Okay, first one mission. Okay. No, let's do this. Let's do list generate. Okay. Python generate app. First one mission. Let's call. It doesn't really matter how you call it. Mission videos and owner. That's my name. Output directory. Generally, we want our app to be in the directory of apps. You can see there are many built-in applications in the CoreFly system, and we also want our customized application to be here too. So, directory here. That's this guy. So we specify our directory here. Now apps. Here I'm just going to call it MPU 6050. MPU 6050 is a 6-axis accelerometer which can take the measurement of acceleration, and this is for the future use, because we are going to talk about the cFS on Raspberry Pi, and we are going to implement the MPU 6050 code on Raspberry Pi with CoreFly system. So let's just call it. So I will just call it the new customized application MPU 6050, just my personal test. Okay, now I suppose we have a mission, we have owner, we have output directory, and we have our app. Okay, as you can see here, we have our MPU 6050 application in a directory of apps. So now let's check what we got from the Python script. Fly software. Okay, source. If you want your application to do anything, list is the file you go to. What we always do is go to app map, MPU 6050-app map. Here it is here, MPU 60 app map. And what I always do to test my code is I print out something. Some people like to print out hello world, and I don't really prefer that. Instead, I like to say something like printf. Go to hell. Yes, go to hell. How do you know you are not already in hell? Alright. So bear this in mind. We are working on the function MPU 6050-app map here. Alright. Other things we need to pay attention to is platform here. MPU 6050 message ID, we need to specify this guy here. We need to make sure every application has its own unique ID, message ID, and all these are default values, so we need to change it. So let's call it whatever, it doesn't matter because we have only one here. Okay, we will go back to this file later on. Okay, performance ID. We also need our app to have its own unique performance ID. Well, let's see. $51, maybe. Who cares? Whatever. Okay, so this is what we do to the new app. But we need to do something else in the apps here. Scheduler. It is good. Platform. Oh, let me see. Yes, it is here. Okay, that's this guy. Here you can see this scheduler include many other message ID .header file from other applications. So we need to do the same thing to our new application, MPU 6050. Include So what's the name of our message ID file? Header file MPU 650 and message IDs.h. Okay, MPU 6050. IDs.h. Okay, another thing we need to do here is we need to specify the housekeeping request. You can see the first here means housekeeping request go out every 4 seconds. We want it to go out every 1 second for our application. So let's call it MPU 6050. MPU 650 wake up MID -1-0. Come on. Also we need to add another track here. MPU 6050 send housekeeping ID. We have done here. Okay. Well, we can delete here. It doesn't matter at all. Apps. Another one. Telemetry. Platform. Here we also need as you can see here, this guy also include the message IDs .header file of all the apps. So our application is not an exception. So we need to do the same thing here. MPU 6050 msgis.h. Right. So far so good. Okay, now we need to scroll down to something. We need to add another ID here. We need to add another line of code here. As you can see here, they have a housekeeping telemetry MID for almost every application. So we need. So let's just add another one for our application. And NPU 6050. Housekeeping. Telemetry. MID 5. MID no 5. 0 0 4. Come on. Save it. Okay, so the scheduler table we have a register for the scheduler table and telemetry table. Here we are good here. So now where are we? Where are we going? We need to go to build CPU 1 and we need to modify the make file here. CPU 1 is where our new executable is going to be. So here, make file. In the make file, they define a variable called the apps, and you can check the stuff the apps variable holds. Sample name, sample app, CI lab, telemetry TO lab, scheduler lab. Actually, they are just the apps you can check from here. They are just the apps. So let's add more terms to this variable. NPU 6050. Save it. Okay. Any typo, any mistakes? Let me see. NPU 6050. No, we are good. Okay. Another thing we need to do here is this guy. That's good. cFS startup script. What we need to do here is to tell cFS, hey, we have a new applications and we want this guy to here. So we want core system to start our new application when the cFS start itself. So that's the reason why we need this script. And copy. NPU 6050. Here's the app. I suppose you still remember the main function we just took a look at. What is it? Let's go back to app to make sure you know what I'm talking about. NPU. Remember this guy? Stores NPU 650-f.c file. Yeah. This guy. NPU 650 app then. Oops. Copy. Go back here. App. You can just copy here. I don't think that really matters here. Another thing to be noticed of is this number indicates the priority of this app. Let's just give it 90. So what's good? Alright. I suppose we already have everything we have. Core persistent view. Let's check again. See whether we missed anything. Nope. I think we're good. So we can go back to CD view CPU 1. We need to go to where the make file is. hold on, I forgot source state. Okay, cd build cd1. Okay, here make real coding first. Make configure. There are many warning. There are many warning messages. Don't give it crap. Yeah. Alright, cd ext sudo core file system. Okay, go to the hell, go to the hell, go to the hell. So congratulations, in this video you just learned how to implement your go to the hell application for core file system. Alright, this is Roy. Thanks for watching.